All right, these are going to be like the rough outline of your notes for lesson 3.1. I'm going to kind of just get you started on some things that you're going to be doing. I'm going to give you some time to work, and then I will post the hard copy of the notes so you can go back and check your work and answers to see if you got them right. In this lesson, you're working with minimums and maximums. And so you need to keep in mind that a maximum again happens when your slope of your function goes from positive to negative, so increasing to decreasing, and you'll have a minimum when it's the opposite, so decreasing to increasing. Now, there's going to be some language differences today. You're going to be working with absolute minimums and maximums, and those happen on a closed interval. And then if we switch to an open interval, you'll be working with relative minimums and maximums. Okay, so we have these pictures, and this is kind of split down the middle here. On the left side, I have open intervals, so I'll just be talking about relative mins and maxes. Now on this first one, I would say there's no extrema. I don't have any places where it's changing from increasing to decreasing. This one has a place somewhere in here that is a maximum, but because this is an open interval, I would say this right here represents a relative maximum. Likewise over here and here, I would have a relative maximum and a relative minimum. When I switch over here to absolute, your lowest point is going to be your absolute minimum. Your highest point will be your absolute maximum, and these can occur at endpoints. For this one, I still have a max here. It is the highest point on my curve, so this will now be the absolute max. I would consider this my absolute minimum, because it is the lowest on my curve. When I look at this one, there's my absolute max. Here's my absolute minimum. So again, for the absolute, they're coming off of a closed interval. The min, the absolute minimum, will be your lowest value on that interval, and the absolute max will be your highest. Okay, let's go back and answer the question. The slope of the tangent line at each relative extrema, we know from Unit 1+, is 0. So that slope is going to be 0 because you're going to have a horizontal tangent. Okay, critical numbers. A critical number happens when your derivative is equal to 0 or when your function is not differentiable. So that could be a place where f prime of c is not defined. Now I'm going to show you something here in a little bit to kind of bring this back to the motion module, because you've actually found critical numbers before. I'm going to take you back there right now. So in Chapter 2 in the motion module, this problem was on the very first page that we worked on, and we were looking for the total distance. So when you guys took your velocity function here and you set it equal to 0, and you found time to be 3 and -1, those were actually critical numbers. So we plugged 3 right into this table, and then we went and found the distance. Well, you're going to be doing very similar things today with 3.1. You're going to be finding a critical number, and it says here that relative extrema can only occur at critical numbers. And so we'll get that here in just a second. You'll see that in our tables coming up. And then what we're going to be doing for the examples is we're going to find extrema on a closed interval. So we'll just follow these steps. We're going to find our critical numbers. Again, that means you're setting f prime equal to 0. Oops, I said that wrong. Let me try that again. Or you're finding out when is f prime of x undefined. All right, we're going to evaluate f at each critical number in the open interval. And we're also going to evaluate the function at the endpoint. So for these two things, we'll be making an XY table. We'll be putting in our endpoints of our closed interval, and then any critical numbers will go in between. The least of these values is called your minimum. The greatest is your maximum. Okay. So we're going to go here. And we'll start by finding our critical numbers. So 12x to the third minus 12x squared. We'll set that equal to 0. And then x is 0, x is 1. These are our critical numbers. All right, both critical numbers are in the interval. So what we're going to do now is we're going to set up an XY table. We will put in our endpoint, and then 0, and then 1, and then 2. Okay. Now then, you're going to be plugging each of these back in to the original function. So I'm going to be plugging them back in here. So let me take out my y here. I'm going to call that f of x, so you know exactly where I'm plugging them in. I'm going to plug in -1, and I'll end up with, what, 3 plus 4, so that's 7. And then I'll have 0, so 0. 1 would be -1, and 2 would be 3 times 16 minus 32, so 48 minus 32 is 16. All right, it says up here, the least of these values is the minimum, the greatest is the maximum. So I would say this guy is my minimum. And he's going to actually be a relative minimum because he's happening at a critical number. But all you have to say is that there's a minimum at 1, -1. So the minimum value would be considered the -1, but we can give a location. And then we have a maximum at 216. Now, 216 would be considered an absolute maximum because it is happening at an endpoint. But for now, don't worry about tying the word relative or absolute to this. Just call it a minimum or a maximum, and we'll be good to go. Okay, number 2, I'm going to have you just try that one. And set up your XY table. Now, keep in mind when you do this one, if you don't get any critical numbers, then you just use the endpoints to test for a min and a max. So I'm going to let you try number 2. For number 3, I'm going to find my first derivative. I'm going to set that equal to 0. I'm going to multiply both sides by x to the 1/3 and divide by 2. So the cube root of 1 is 1. Okay. Set up my table. Let's see, we want -1, that's the endpoint. We want 1, that's our critical number. And, oh, I forgot a critical number. Let me go back. Critical numbers happen not only when our derivative is 0, but they also happen when, So there's a critical number. They also happen when our derivative is undefined, and our derivative is undefined at 0. So we need to also include that in our list. Okay, so again, critical numbers. In the first problem, I didn't have to worry about the derivative being undefined. So it just had 0 and 1 as critical numbers. In our third one, the critical numbers are going to be 1 from setting the equation equal to 0, and 0 because this derivative right here is undefined when x is 0. So you have to use both of them as critical numbers. All right, now let's find the y values. So I will have, let's see, 2 times -1 would be a -2. And x, let's see, -1 to the 2/3 would be the cube root of 1, which is 1. So that's going to be -2 minus 3. That's going to be -5. 0. I'm putting 0 back into the original function, so that's going to be 0. For 1, it would be -1. And for 3, that's pretty messy, but it's going to be 6 minus 3 times 3 to the 2/3. Now, if you wanted to pop that into your calculator, you could, and you could see what you get there. I'm going to do that right quick so I can get a good decimal approximation. 6 minus 3 times 3 raised to the 2/3, which would be the same as 9 to the 1/3. That's -0.2-ish. So I can see from here that my lowest value is here, and my highest y value happens, let's see, highest would be 0. And so I'm going to say that I have a minimum at -1, -5, and I have a maximum at 0, 0. Okay, number 4, I'm going to get you started, and then I'm going to let you work with your trig to see if you can get it done any further. So f prime of x is 2 cosine x minus negative sine 2x times 2. I just had to use my chain rule. So f prime of x is 2 cosine x plus 2 sine 2x. Now, I'm going to let you kind of just leave you stranded here for a little bit. I want you to go back and look up your trig identities from last year and see if you can't solve this equation and figure out your critical numbers for x. There's going to be several. I'm going to let you play with that for a little bit, and then later in the day I will post the actual key to your notes and you can check yourself. So you will be taking all your critical numbers and you will be inserting them into this table, and then you're going to have to find your y values, and there's a little bit of work to that as well. So rather than spend 20 minutes on your video working that out with you, I'm going to have you just try it, see how far you can get, and then you can check the hard copy of your notes later. I just want to talk to you about the practice problems real quick. So one set of the practice problems, and I must have lost my blue box here. I'm not sure what happened to it, but these are all practice problems here. So it just says to find the value of the derivative at the extrema. So I have highlighted where all the extrema are, and I do want you to actually find the derivative and tell me what happens when you plug in the x value. For example, on number 2, when I find my derivative and I plug in 0 for x, I should get f prime of 0 equals 0, because this would be a horizontal tangent. What you're going to do in your assignment is just show me that when you actually find the derivative and plug in 0, you get 0 for an answer. Likewise, when you're down here, I want you to actually go ahead and find your derivative, plug in -2 for x, and show me that you get that f prime of -2 is undefined. And I know it's undefined just by looking at the picture because there's a cusp. But I want you to go ahead, find the derivative, try to plug in -2, and then come to this conclusion right here. So you're going to be doing that on 1 through 6. On 7 and 8, you're finding the critical numbers. So that's when the derivative's 0 or when it's the derivative's undefined. And that means it's not the function would not be differentiable there. And then on 9 through 13, those are just like the examples. So see examples. You're going to be finding your critical numbers, setting up the XY table, and so forth. And you're going to tell me about the absolute extrema on the interval. And again, if you just tell me if you have a max or a min, that's all I need to know. And then on 14, you're going to tell me what each of these points represent. And 15 is an application problem. All right, don't forget to come back later and check your notes to see if you have number 2 and number 4 correct. I'll let you work those out on your own, and I'll post those later in the day on Tuesday or Wednesday. Depends on which day you look at your notes. Talk to you guys later.